In this video, I'm going to show you a few examples of evaluating limits as x goes to infinity. So here, let's evaluate the limit as x goes to infinity of 3x plus 1 divided by the square root of 4x squared plus x. The first thing that I'm going to do is I'm going to go to the numerator and factor out the highest power of x that shows up. And then underneath the square root, I'm going to factor out the highest power of x as well. So I'm going to factor an x out of the numerator and an x squared out of the radicand. So the numerator becomes x times the quantity 3 plus 1 over x. And underneath the radical, we have x squared times the quantity 4 plus 1 over x. All right, next I'm going to, so if we have the square root of two things being multiplied together, it's the square root of the first times the square root of the second. So I'm going to simplify this denominator. So here we have the square root of x squared times the square root of 4 plus 1 over x. And now I'm going to simplify the square root of x squared using the fact that the square root of x squared is equal to the absolute value of x. All right, we're getting a lot closer now. So I'm going to use the fact that x is going to infinity. So it means that what we're examining is what's happening to this function here as x approaches a really big positive number. Okay, so now I'm going to rewrite the absolute value of x using this fact. So we can rewrite the absolute value of x as a piecewise function. It's equal to x if x is greater than or equal to 0, and negative x if x is less than 0. So again, x is going to infinity, so we're concerned with positive values of x. Therefore, the absolute value of x is equal to x for those inputs. So we get the limit as x goes to infinity of x times the quantity 3 plus 1 over x divided by, instead of absolute value of x, we have x times the square root of 4 plus 1 over x. And now we get to do some simplifying. These x's cancel out. So we get the limit as x goes to infinity of 3 plus 1 over x divided by the square root of 4 plus 1 over x. So this is pretty straightforward to analyze now. So as x goes to infinity, 1 over x is going to go to 0 because we get 1 divided by numbers that are getting bigger and bigger and bigger and bigger, and that fraction goes to 0. Likewise, this square root of 1 over x in the denominator goes to 0. So we end up as a limit 3 plus 0, or 3, divided by the square root of 4, and the square root of 4 is just 3/2. Okay, so the limit is equal to 3/2. Okay, so here, actually I want to send x to negative infinity instead of infinity. So evaluate the limit as x goes to negative infinity of x plus 6 divided by the square root of 7x squared plus 4. Press pause while you work on this one. The first thing that we're going to do is factor an x out of the numerator and an x squared out of the radicand. So we get the limit as x goes to negative infinity of x times the quantity 1 plus 6 over x divided by the square root of x squared times the quantity 7 plus 4 over x squared. Okay, now I'm going to do the same thing. I'm going to simplify this as the square root of x squared times the square root of 7 plus 4 over x squared. Okay, now the square root of x squared is the absolute value of x. Okay, now I'm going to rewrite the absolute value of x. And I'm going to note that here x is going towards negative infinity. So we care about negative values of x. Therefore, when we rewrite the absolute value of x, we're concerned with negative x. So therefore, the absolute value of x is equal to negative x for the values of x we care about. All right, now we get to cancel the x's again. So we're left with 1 plus 6 over x in the numerator and negative square root of 7 plus 4 over x squared in the denominator. All right, now we know that since x is going towards negative infinity, 6 over x goes towards 0, and 4 over x squared goes towards 0 as well. Therefore, the value of this limit is 1 plus 0, or 1, divided by negative square root of 7 plus 0, or just 7. Okay, so the value of our limit is 1 over negative root 7, or we could write it as negative 1 over root 7. Okay, here's one last example. So as x goes towards infinity, this term right here goes towards infinity, and this term right here goes towards infinity. So this is the kind of infinity minus infinity case for evaluating limits as x goes to infinity. And what we're going to want to do in those cases is introduce a fraction. So what I'm going to do is I'm going to rewrite that as the square root of 4x squared plus 2x minus x all over 1, and then I'm going to multiply the top and the bottom by this, but instead of having a negative sign, I'm going to have a plus sign. All right, now I'll multiply across the top and across the bottom. So the square root of 4x squared plus 2x times the square root of 4x squared plus 2x, we just get 4x squared plus 2x. Then we have plus x root 4x squared plus 2x minus x root 4x squared plus 2x, so those go away. Then minus x squared. Then divided by this whole term times 1, which is just this whole term. Okay, now 4x squared minus x squared is just 3x squared, so we can replace that. All right, now I'm going to do the same thing that I did in the previous examples. So I'm going to go to the numerator and factor out an x squared. And I'm going to go to the and that's because that's the highest power of x there. And then I'm going to go to the radical here and factor out an x squared from the radicand. I'm going to leave this alone for a second. Okay, now I'm going to simplify this term by writing it as the square root of x squared times the square root of 4 plus 2 over x. And now the square root of x squared is just the absolute value of x. Okay, and now we're concerned with values of x going towards infinity, which means we're concerned with positive values of x. So I can replace the absolute value of x with x. Okay, so now I'm going to worry about this x here. So I'm going to go to this denominator and factor out an x. Okay, so whatever the highest term is, looking at the term in front of the radical and the other term, I'm going to factor out that highest power. That happens to be x. Okay, so I'm going to factor an x out of this denominator. Okay, so I have square root of 4 plus 2 over x plus 1 inside the parentheses, and now I can take this x here and cancel it with one of those x's. So I'm left with x times 3 plus 2 over x in the numerator, and this term here in the denominator. Okay, now I'm ready to tackle the individual pieces of the limit. So as x goes to infinity, this 2 over x goes towards 0. This 2 over x goes towards 0 as well. So in the top, we have x times 3 plus 0, or just 3 times x. So this top is going towards 3 times x. The bottom is going to the square root of 4 plus 0, or just the square root of 4, or just 2 plus 1, which is 3x over 3. So the top is going to 3 times x. The bottom is going to 3. So as a whole, the fraction is going to just x. Okay? So the top is going to x. The bottom is going to 1. So as x goes to infinity, this whole thing goes to 3x over x as x goes to infinity, which is just infinity. Okay? So the value of this limit is equal to infinity. So therefore, the limit does not exist.